All right, folks. Well, good to have everyone. It's been a good week. Well, just hold on for a few more minutes. I think people are still coming through and stuff. I know that there are other sessions as well in parallel, but it's myself, and we'll get going with a couple of good things. I tried to make today a little bit more interesting than the usual, if that's the case. Why? Because I want to talk about AI and actually look at things from the ground up, so to speak. Because I feel like it's probably a session that's been well overdue. I've talked about ChatGPT and other things in passing, but let's go through CatGPT instead. Meow meow. Right, so AJ, if this is something that undoubtedly CatGPT we've all purred with a few times, but I thought it'd be a good place to start today. So Fridays are a little bit of a wild card. We know we can do other things too, but AI is something that has just my newsfeed is entirely of it, and I'm starting to get really good at disambiguating like what is AI speech, who has been using AI kind of copywriting tools and so on. And I think the world is screwed forever. The dead internet theory is real. I am so aligned to it now that I can't unsee it. So I'm going to bring you into my miserable world of, of recognizing AI chats, okay? So I thought we would do this. We'd go for a full explainer of GPT, if we can do that today, if we've got the 2 hours to, which we all by now have used and probably have seen or heard of, the revolutionary AI chatbot that can write poetry, it can pass the bar exam, it can fabricate celebrities like Machine Gun Kelly. No, you can't convince me that that is a real human being. Machine Gun Kelly is not a real person, and not the ghost of an old tattoo that haunts young women. Who, folks, has used ChatGPT today or in the last, this week, let's say? So what use cases would you typically think of if you go for that? Nick says, yeah. If you can, maybe if you're going to tell me what use case you perhaps used it in, or in what sense, for what ends, what goals, perhaps, to review. Okay, how did that go? So once a week, what if I was like, I'm like a junkie. I'm like once every 5 minutes. I have the kind of on hotline. So once a week. That's more of the conservative end, and that's coming from me being so disposed to it. Cool. Analyze the photo for a Kenyan farmer. That is really interesting. As in, you passed it in, and then the model had analyzed it in some sense, or told you what it thought. Chicken disease. Okay. I can't imagine that was a fun conversation. Well, if that's impressive. Oh, cool, Manpreet. Yeah, and as well too. There are summits ongoing throughout the year, not just the big one. How did that go, Manpreet? Did you get any goodies? I wasn't aware of that such a thing. AI summit in London. Oh, it's not, sorry, not AWS thing. It's just a AI summit. Is that right? Oh, yeah. Cool. Like drinking an ice cold drink fast, brain free. Oh, right, cool. I'll come back to that one, Will. This is a real cool one. As you can see, these things are getting really exciting. Doesn't look like Andy from behind. That's super strange. So that's a fun one. Mind you, you can also try out for other events that aren't actually necessarily in the calendar. By the way, if you have an email address, sorry, a business email address, and not your Gmail account, but like a work email address, I would always recommend trying to go for the AWS exec summit, which is the day before the plebs summit, the one that all of us can attend for free. Well, the only thing they require here is just a business email address, and the rest is free. They treat you really nicely. I go every time I can, and they treat me really nicely. You get to rub shoulders with really smart people. You just say, yeah, and it just makes it up. I use my name for it, and then no one asked me. But anyway, I'm really interested in that one, Will. So I asked me to show different color options for wheels in the car. Again, so just like Nick's use case of uploading an image and then picking out either patterns of data or thinking opinion pieces about that. Really interesting. Clearly, there's a lot to it. And over the last couple of months, we've seen more use cases around this. And for good reason, because ChatGPT from OpenAI is now the fastest growing consumer application in human history. But much like the persistence of Machine Gun Kelly in pop culture, chatbots are really hard to understand. Yeah. So I thought today what we do is we go through everything that you possibly would want to know about ChatGPT, how it was made and how it actually works, and where technology like this is actually headed. So first of all, the basics, right? What do we know about ChatGPT? That it is a publicly accessible chatbot. The variant of it, version 4 now of that, is it's what's known as a large language model from a company called OpenAI, which might be closed AI. More on that second. Anyway, this is a sort of non-profit, maybe profit tech bro company that was founded by like an Iron Man villain and other tech bros too, that basically took a large language model and produced some interesting things from it. Okay. Now, GPT, as what we can think of, the actual chatbot variant of this, is an acronym. I think we all kind of figure that. It's not a really easy thing to say, but it's entered the vocabulary. We've stuck with it now. It actually stands for a generative, in the sense that it is non-deterministic. It can kind of produce some stuff, later on. It can generate ideas. It generates text or images or foot and mouth disease in chickens, whatever it is. It's pre-trained, because that means it's, beforehand, it's been trained before it's let loose on anyone. And it's a transformer. Not in that sense, because rather it's got this bit of technology inside of it that's called an attention transformer. But we'll get to that, okay? The basics of any large language model is so that we start training on a substantial amount of text, and then we kind of given some inputs, what we then output is something that sounds like that training text. That's the bottom of it. I'm just going to move my keyboard because I've got T in the way. Now, it seems like these terms are a little bit all over the place. They seem to have sprung up overnight, and that's because they basically have, folks. You've all used it, but by the seams of it, rather recently. Though, if you look back, it was first announced back in OpenAI's blog back in 2018, and just here we are 6 years later, 2025, it has amassed 100 million users, active users within the first 2 months, which is huge. That's like the amount of households in the US. Like, it's such a compelling technology in so many ways, and to so many, just because of how good it is at talking in a very human-like way. But large language models, they only get to that point after seeing a lot of human conversation, okay? Like, all of it, essentially. So, I thought I had a paper. Yeah, according to one paper here by GPT-3, so this is the one from which ChatGPT really originated or kicked off with version 3, the one from November, right? And this was trained on 500 gigabytes of text data, from the text of the internet, on digitized books, on Wikipedia, and more stuff. And we're talking about several billion human-written web pages with trillions of words of text and more than 500 digitized books with, billions and billions of words of them. So that, not to mention, again, all the public code that comes from GitHub, from Stack Overflow, from other sources too. So as you can imagine, with a lot of stuff going into the model, a lot of training, a lot of text that takes an awful lot of time, a lot of money, a lot of energy as well. ChatGPT was only really born after running trillions and trillions of words, or the equivalent of about 300 years worth through supercomputers and processing that in parallel for months. And after all of that together, the computer made about 170 billion connections between all those words. And with all those connections, they have to be then calculated by whoever then asks ChatGPT everything. So, which is why, it's a multi-billion-dollar training effort just to get going, to have a large language model like ChatGPT, and then running this bot like for 100 million users or so, like we saw before, might cost you, millions of dollars a day. It's an awful lot. It's really big. Large really is an understatement of the year. Okay, so just to recap, it's a large language model that can help out with Lambda functions. It can help out with almost anything because it's been fed an entire library of Alexandria's worth of text, of data, of AWS documentation, and from that calculation, it's then gone on to make billions of calculations of connections between words and text. And we'll get to specifically how that works in a bit. Okay, so all of this training data comes through, which is how it forms those connections, how it's able to imbue that information through, so that it can then produce what's known as a reasonable continuation, as Stephen Wolfram puts it, or of text. So in response to prompts, the model's responses, what comes back, it can produce things that sound rather fresh, quite human-like, by doing this, by adding actually quite a sprinkle of temperature through. So that means that the next word that it picks from the next probable continuation, I think this is the first real major takeaway from this, okay? That all that ChatGPT does is it adds one word at a time to a prompt. That's it, okay? Though it does do this extremely well, but how do you try to make the words that it adds at the end of the prompt align with what we think is a reasonable continuation? What do we make it think is somewhat accessible in that sense? Because ChatGPT is quite special that the model includes an attempt to solve one of AI's biggest, most pressing unsolved problems, that of alignment, the alignment problem. Is that a thing that people have heard of or come through before? The alignment. So it's a problem that comes out far field sometimes. Not necessarily in the sense of cloud computing, but in AI. I'm wondering if anyone's heard of that before. Okay, so to some, you might have come across this maybe in like scary sci-fi or books or the literature the like. What this is, basically a quest for you to go and figure out how to get AI to value, what we humans like, okay? So how do we make an AI aligned with us and not, exterminate us when we put guns on them? I can't wait. So we have seen problems with this already. It's been around for some time now. Define AI alignment. There's a great thought theory about this called the paperclip maximizer, which I'm not going to get into, but I'll go and suggest having a look at that rabbit hole if you want to, okay? So AI alignment is the process of making sure that the AI system behaviors aligns with us. It values what we want, values and goals. And it involves making AI models as helpful, safe, and reliable as possible by encoding human preferences and expectations to the design. Has anyone read the I, Robot book, the short stories by Isaac Asimov? It is really good. Not the movie, not the Will Smith movie, which has nothing to do with the book. Like, other than the title is zero. The book is phenomenal. It might be my favorite book. So I, Robot, the book starts with the opening chapter about great, yeah. So you remember that you've got a couple of laws of robotics, if you will, and these laws often terminate. Well, they finish with this ominous statement that then it then informs the rest of the book, and they kind of play around these decisions that a computer has to make in order to think through. This was way ahead of its time, so ahead of its time, before the end of the Second World War. Okay, that's how long ago this book was written by. Anyway, so the three laws presented to this A robot may not injure a human being through inaction or allow a human being to come to harm. They must obey the first orders, where it can't hurt a human or even by absence hurt a human, such as where the orders would conflict with the first law. And then it also must have some own self-preservation built into, as long as it doesn't conflict with the first two. And you have really interesting thought experiments, and that's really, really good. So sci-fi aside, alignment is becoming a real problem. And we've seen what happens with this when a chatbot gets released to the public without being aligned to general human values. I wonder if anyone knows their internet history enough to remember this on Twitter a few years back. Yeah, it gets so racist so quickly. Yeah. So not a good situation there too. And so ChatGPT was not just trained on words, but also on how well it selected words and how it then aligned those words with those values that OpenAI describes. So I've just shown you Isaac Asimov's ideas or his values. But OpenAI have the values in terms of truthfulness, helpfulness, and harmlessness. That's it. So OpenAI's values are helpfulness, truthfulness, and harmlessness. They could have chosen easier words. So this company, they implemented this alignment with so-called reinforcement learning from human feedback. Okay? So that means during the model's training, if you remember a few weeks ago, I did a session quite like this one, and I got Charlie to kind of flip a pancake with his phone, and I positively reinforced him and said, good job, keep it up, +1, and negatively reinforced it with a, bad Charlie if he got it wrong. That's the kind of thing that we're trying to do here with reinforcement learning from human feedback, which means that during the model's training, OpenAI hired about 40 contractors just to rate responses. They then used all those responses to create another model that then rewarded ChatGPT for generating that aligned text, that positive reinforcement. It's called a GAN. It's called a generative, what was it? Something, the adversarial network. AI GAN, something adversarial network. Yeah. And then basically one side of this brain says, here's this, and the other side of the brain has to fool the other side of the brain, and then progressively gets better and better. It's really clever how it works. But taking all this together, the end result is that we have the responses to create, and then we have to say good or bad. Okay. The end result is that it's not perfect, but it's an attempt to solve the biggest problems we have right now facing AI, which is that, who knows what can come out of it. Taking all that together then, a model that's going to be trained on more text than any human could ever possibly read, or even guardrails that you could try to prioritize your human values, and then a user interface that just isn't entirely crap, then you get an AI chatbot that is like this and has just exploded in popularity, like insane. So again, it had, I think in just 1 month, it had about 2 billion visits, making it one of the most visited websites of all time in the world. Both in Reddit, both in Netflix combined. Yeah, here we go. About 2 billion monthly visits in one go. Absolutely enormous. And that's old data too. So in this case, if we assume then that each of those visits produces some kind of an average text or a response length, ChatGPT is now outputting something like everyone humans has ever printed since the Gutenberg press, okay, every 2 weeks. So text generated by AI will therefore soon outstrip anything that we humans have ever written. Like, we're getting close to that dangerous point where we're just about to tip off, if it hasn't already, where even more than all the tweets about the World Cup and England missing and all that other stuff, that much amount of data, okay? Of course, that means that this enormous output, it wouldn't be very interesting, it wouldn't be that useful if it actually wasn't truly interesting or useful. So ChatGPT is disturbingly good at generating human-like responses, even against the most difficult questions. It's been shown that it's got an IQ of about 150, which means that it can brag about it on every thread on Reddit. It could also legally pass the US medical licensing exam. It can pass a bar exam. Like, it's been shown to be really good in a lot of different fields. And as book smart as it may be, I had to stress again, the model is fundamentally dumb. It doesn't know anything. Yeah, it shouldn't be relied on for anything extremely important. In fact, you actually see this sometimes at the bottom of the page on ChatGPT. It says, take things with a pinch of salt. Well, not literally that, but it says, check information first, or check valuable information. Answers can be wrong, something to that effect. Like similar to this at the bottom, sample photo text on my part. Clearly not that. But there's a direct quote from OpenAI themselves that say, terms and conditions applies. It could be BS. And so despite that, what any weirdo at Google might tell you, this guy's an absolute crackpot, Blake. But let me tell you, okay, ChatGPT, other LLMs, they are not sentiment, okay? They do not know what's going on. And if you're thinking, if you're not asking the model a question, there's nothing going on inside. It's static. It's no thoughts, empty head, yeah? Knock, knock. There's no feeling inside of it. There's no experience of what it's like to be ChatGPT. There's nothing in there. So the high-level basics of that. But I just wanted to get to how ChatGPT knows what words it actually uses. How does it understand what context is in when you give it a prompt? So I want to go into the more technical bit of today, if that's okay with you. But first, I wanted to go for a little break to your brain. I can sense that you need one. So what I wanted to do is just watch along with a video with you, and we can discuss things as I go through, okay? Let me know if there's sound coming through. If not, I'll play around with the settings. I'll assume that there's sound. Oh, sorry, I clicked off. All right, so this is a deepfake video with...
Hello everyone, my name is Ryan Gosling. Howtofly asked me to give you a quick introduction on the text-to-text capability of generative AI. So if you're AI curious, AI unknowing, or just AI confused like I was, here's my introduction into the fascinating world of text-to-text generative AI. Can I have a blackboard, please, to help me explain the concept of text-to-text generative AI?
It's multimodal too, so I can also produce images.
Awesome, thanks. So what are large language models, also known as LLMs? A large language model, or LLM, is a type of artificial intelligence model designed to understand and generate human language. It can execute tasks such as translating languages, composing text, answering questions, writing code, summarizing lengthy documents.
Yeah, and so on and so forth. So the things we said, just all the things you've given me answers for, all the reasons you might use a chatbot.
Generating creative content,
engaging,
providing simple explanations on difficult topics, and even engage in human-like conversation. Some well-known examples of LLMs include GPT-4 by OpenAI, Gemini by Google, Claude 3, Opus by Anthropic, Mistral by Mistral AI, Llama by Meta.
Okay. So I want to just talk about quickly about why these companies have come through and not everything. Well, first of all, if I put that distinction out, I don't know if it goes on to say if they're close. Like
Mistral and Llama, meaning anyone can use, modify, and share them just like a recipe that's shared for everyone to cook.
Okay. So what they're talking here about the difference between commercial and open source, and I just want to throw that out there for yourselves. If you can, touch on that subject, what does that mean to you? What do you instinctively know to mean open source? Let's start there. If I say the word open source, what connotations does that bring with you? What does that mean for us in this situation? Any thoughts on open source? Nice. Anyone can access and contribute. So we are in the context here of AI, can contribute to ... some kind of software, right? Well, open source software in that case just means that anyone that the code is going to be implemented in that software, be it in Python or whatever, like any number for like, it's all open source. That is that you and me and Chantel and anyone on the internet typically can go ahead, read the source code, and because it's open, see exactly what the instructions are. They can access what's in there, and then it's going to be executed on your computer or your phone. Now, that doesn't necessarily mean that the version of the software that you're actually running is exactly the same as the open source version. Like there's still a threat whereby like the code might be open source, but you were tricked into some phishing email or some malicious website just to install a fake version or some software that actually has malicious code inside of it. But well, there might still be a problem. I don't think that's really the case in this here. But a lot of folks will often think that open source, like Chantal says, it's a good thing often. There's no lock-in. That might be a good thing in the sense that you might be able to then audit. Smart people on the internet can actually go ahead and look at it, audit the code, make sure that there's no backdoors or any malicious instructions or it might be able to do things that you wouldn't expect the software to be able to do. Now, again, that's not necessarily the case, and that the version that you're using or the running doesn't have form of, anything nasty, but it might give you a bit more reassurance. And it's also, for the people, by the people. So there's not a lot of money involved. Now, on the flip side, funny how GPT, OpenAI is anything but. That is like if the code was open source, like even if it's devoid of anything malicious, like it still could have bugs, it still could have mistakes. The human programmers that wrote this stuff, which are human, which may very well have been if it was open source or any software, it might still be vulnerable to attack. I mean, like if you're literally giving the adversaries the plans to your software, it's like the plans to the Death Star in Star Wars. Yeah, such that can probably go ahead and figure out what the weaknesses are in your software because you're giving them the blueprint. Here's instructions, right? So an alternative to open source is perhaps the default, which is that of commercial closed source software. So again, any software that you might be able to download or buy from companies that's typically not open source or typically closed source, which means that only the employees, only the people behind it have actually access to it. Now, what's the downside to that, perhaps, as the user of using such a closed source software? Any thoughts on that? Any ideas as to what could be a limiting factor in a world where only the authors, therefore, have access to that? Yeah, exactly. Limited information. Take that further, Valentine. What's the upside, arguably, if you have limited information, then perhaps what happens off that? I mean, what about a bad person? What if, arguably, Valentine, if you were an evil person, if you had limited access as well, you kind of don't have much you can work with, right? So bad people on the internet might not have access to it. So just the probability that software not only has mistakes, but also those mistakes are exploited, perhaps a little bit lower. And so this is much, again, more of a debate. It's more an art than a science. And you could consider that this might have to open source versus closed source. But another argument of perhaps open source is that with so many people around the world, and especially when it's so big, a lot of eyes on software, perhaps actually increases the probability that someone's going to be able to detect bugs or potential exploits because just so many people are looking at and then therefore weighing in. There was one that attracted a lot of information or a lot of chatter recently. I'm wondering if anyone is privy to the model that doesn't appear on screen. Was developed in China. and was a little bit of a stir some time ago. It did knock the Nvidia stocks back somewhat. DeepSeek, Chantal, exactly. So to expand on the global implication of DeepSeek, has anyone used it or did get around to seeing why? Let's talk about this for a sec. This is so annoying that I can't even get results until scrolling down. So this the thing that made it such a splash is the fact that it was open source. I can't find a good article. I'm just going to pick out this one, okay? So the fact that it was open source is a really big deal because, again, software folks tend to prefer open source options over closed source. So in the future, that AI ecosystems, tools and strategies of the industry will likely give preferential treatment to things that look more like DeepSeek over things that look like ChatGPT, unless something really changes. Also, in the world of America, like they've been pretty easily able to justify prohibitions on using Chinese tech in the past. DeepSeek's AI being open source actually makes it quite difficult to make that same justifications against it because just about everyone now can see how it was made. And the whole world would be now aware, like if something was doing anything suspicious. And it turns out it's not. Like you can just run it in a box on your computer offline. So it works without the internet. And then Nvidia who produced the rival company here behind OpenAI, they're worried because DeepSeek proved that you just don't need as much of their hardware, the graphical processing units, so that you can train AI, their A100 chips, which is what AI uses. Well, Google use it, Amazon, Meta. They're all worried because they've been so exposed to having inflated cost of developments. And again, they're in danger of losing their ecosystem preference to an open source contender. The US government's really worried about this because they spent the last decade and a buttload of resources like trying to hamstring Chinese tech companies and just giving expensive contracts to American tech companies, to Amazon, only for China to just catch up overnight. Again, also the current administration they've just announced like a very, very large investment into AI. Deep proved to be overvalued. So everyone should at least be somewhat interested in this because companies have required so much energy as AIs that it's been a real sizable impact on them. And they're also considering their own nuclear power plants and so on. DeepSeek just proved that you don't need to run anywhere near as much as they're using. It's not about trying to come to the US, it's about open source catching up to it.
There's our commercial.
Okay, so let's see a little bit more how it works.
Support unique features to businesses. How does an LLM actually work? Text generation by large language models like GPT-4 involves a sophisticated process that converts a given input text into a desired text. Let's go over a simplified version of this text generation process, starting from user input all the way to the generated output. First, we'll talk about the input prompt. Let's say I ask the following question to a large language model like GPT. Please give me a short speech of a Premier League football coach who wants to motivate the team at halftime when we are 0-2. Thing the LLM will flip the prompt in smaller, more manageable pieces. This is what
Oh, hello. Hi, folks. I'm back from seemingly nowhere. Hey, sorry, I think my internet dropped off for a sec. But you're all here, so that was my problem, not yours. Apologizing. Let me just, what happened was the government heard in and they weren't happy. Okay, sorry about that. Let me just get back to where I was. I'll just reshare. I can send requests. What am I talking about? Why can't I share? Oh, there we go. Sorry, folks. It's gonna be fine. No, it's my fault. Sorry, Will. So what was going on? Basically, before it all went haywire, what we do is we take inputs to a request, and let me show you something. Platform, OpenAI tokenizer. We'll go into this in more detail in a sec. But the point being that when we make a request to the model, it goes through a series of 4 stages. At the first stage, the transformer tries to break down the inputs into much smaller constituent parts, and they're known as tokens. So in the case of a sentence like, really sorry that my internet is crap, then those tokens, they might be made up of constituent words or phrases or even sometimes like individual characters as well, like a space or a full stop. I said, hopefully it works. So not a good example there, but sometimes you can get them coming up in slightly different configurations depending on the model. Yeah. Anyway, yeah, so like different tokens, the point being here. They've just gotten quite good at, well, I'll explain why these models seem to understand constituent parts
depending on the model's design. But in most cases, a token equals a word. So in the future, whenever I talk about a token, think of it as a word. Here's how GPT-4 would tokenize our input prompt. Every colored piece of text is a token. So in this example, the long token, so that a computer can fully understand the token or word. So let's pick the token motivate as an example. This can, for example, be turned into the following initial embedding. The numbers in this embedding vector represent the complex semantic properties of a token. 0.95 might represent the likelihood that the token is a verb. 0.87 might represent emotional intensity of a word. Minus 0.
All right, so what's going on here? The second part of this, we just said we take a word, we string it up, and we put it into tokens, numerical representations of such. Why? Well, just because computers prefer numbers, and numbers are a better thing to run statistics on. So why don't we do something with them? What we'll do is we'll create a numerical identifier. And what we'll take these numbers with, sorry, before we get to that, what we want to do is we take these tokens and turn them into numbers. We turn them into a numerical identifier, which we're going to call an encoding. So it looks a bit like this. Further in, what we have is our encoding. Yeah. So our inputs are, actually, let me just use a simple one for now. Mr. Lion famously is always sleeping. Don't know. Okay. Now, if we look at this and we pass that into an encoder, what happens is that each of those words, each of those tokens, needs to be thought of in some kind of a number sense, and we're going to call that thing an encoding. Now, these token encodings here are going to be turned into something that we're going to call embeddings, and these embeddings are like multi-dimensional numerical representations of that word. Mr. Lion famously is always sleeping. Looks like this. Okay, these numbers, they end up capturing that semantic meaning of the word. This is what natural language processing is all about. So that, I mean, we're going to look at a very simple example here. Just my line is famously sleeping always. And I'm going to show you this in a very simple three-dimensional embedding, okay? So that if I were to take that into a three-dimensional embedding, basically just for the sake of understanding, really simple, what we have then is our x-axis, our y-axis, and our z-axis, okay? 3 dimensions, or it could be 2 if you just want to make it 2D. So this is going to be a 3D visualization, and we have like, we're going to see. If I press play, this is going to do, it's going to plot the coordinates of cat, lion, dog, wolf, elephant, goldfish, and spider in this 3-dimensional space. Following so far? Yeah? So what we want to do is we capture the semantics of the words, turn them into numbers, and it looks a bit like this. So there you go, yeah? Now, if I say cat, here in blue, where's cat? So cat might have the coordinates of, again, in this 3-dimensional space of 2, 4, and 5, and guess who's next to cat? Well, wolf and lion. And that kind of makes more sense in this 3-dimensional space, I guess, because they are somewhat feline, you know, they're quite similar in meaning. So that embedding is going to be quite close. Now, if we start to write down the coordinates of feline, then it's going to be up here somewhere, right? You can imagine that kind of four-leggedness as relating to the space up here. Yeah. If we look at maybe something like dog, you know, it might be down here to the bottom. Dog is semantically quite different in terms of, you know, the type of animal, but it's still really similar to wolf because, again, it's an animal. It's got 4 legs. So maybe, I don't know, these numbers, of course, don't mean anything. I just put them in arbitrarily. But the embeddings might be something around here too. So what we can see then is that words with similar meanings, as opposed to goldfish and ants and spider, they are located or clustered together in this vector space. And the idea is that words with similar meanings, maybe even though, you know, they're very different in the word itself, we can see how similar they really are. And that's, again, made possible because words have similar embeddings. And that's, again, really, really simplified because this is just using a 3-dimensional vector. Yeah, so 3 dimensions. In reality, ChatGPT has hundreds of thousands of dimensions, depending on the vectorizer that's being used by the model.
0.45 could relate to the current performance level. And in this way, a huge amount of numbers in every embedding represent the detailed, complex semantics of a word. So where are the values of these initial embeddings coming from? The values of these initial embeddings are based on the parameters received from a pre-trained model. This model has been pre-trained on a huge amount of...
Yeah, that's the PT in GPT. That large language model, that kind of trapped lightning in a bottle, is because it's been trained up already.
Coming from books, articles, conversations, movies, etc.
It's like that baseline of IQ that you can then go off and fine-tune it further, or turn it into a large language model. You can then turn it into an image generator, whatever kind of intelligence you want out of it.
By doing so, the model has learned the complexities of the human language.
It speaks really slowly. I'm just going to get things going, okay? A little bit faster.
Important to be aware of is that if you use the same language model on the same token, the initial embedding will always be the same. So the initial embedding of motivate will always be the same if you always use, for example, GPT-4 with the same pre-trained model. Now we have arrived at a crucial step in the process, a step that really revolutionized how LLMs work. The transformation of the initial embeddings into context-aware embeddings through what is called a self-attention mechanism. Through this step, the model identifies the most important words and nuances in the input prompt needed to generate the most relevant output. So let's go back to our example. Although the word motivate might start with an initial embedding.
All right, boring. So the next step here is what we want to go into see as the decoder. So after all those tokens have come in through here somehow, as well, like the positioning was saying that it's always going to be the same relative if it's the first word in the sentence. That's true, but he's kind of neglecting to mention that everything else depends on the meaning of the rest of the phrase. We'll get to why parallel that matters in a bit, okay? Why the positional encoding matters. But so after all the tokens have been encoded, that transformer architecture is going to process that input sequence coming through using something it calls the self-attention mechanism. And attention is in that case because for a lack of a better word, like parts of those numbers, they attend to other parts in the sentence. Like that's how language works, you know? It's messy. It has double entendres. It has meanings kind of imbued inside of it. So you want to soak in context. Before you start to weigh the importance of different tokens in that sequence, you have to kind of listen out to your neighbors. So this lets the model start to consider also the entire context of that input. So that's the decoder part of this transformer. It generates then the output, which is again going to be another vector representing not just a single word, but also the probability of tokens in that model's vocabulary. So you was going to say that the token is going to be the next word in that context, no pun intended, of transformer models. So context relies to the ability of the model to understand the preceding context when you're understanding future text. Let me prove this to you. Okay, let me make this a bit more fun. How can I do this? I'm just going to get my... So, can we play a game where everybody, starting alphabetically, can you tell me a word, just a word, or a short phrase actually, just tell me something that you'd like me to write that into chats so that we can see and we can use them as examples. So if you just like to put a short phrase, just one word, like a couple of word things, what I'm going to do is I'm going to show you how that might work. All right, so I'm going to... Spider-Man just popping up there. I saw Spider-Man the other day. True story. All right, so I'm just going to use my phone as an example. That's coming through. I believe that you can see my phone. Yeah, folks. Please, can you tell me? Swipe up on the screen, press a power button. There you go. Is that coming through? Yeah. Can you see my phone on screen? Just so I can make this a bit more interactive with you. Yeah, cool. Now, so what I'm trying to do is prove again this world of context. Yeah, and context in the sense where you have the ability of the model to understand the preceding context, kind of the antecedent word when you're generating future text. So if I say, for example, the last word I saw in chat, which comes from Will, and he says the word yes, then the next possible word, is going to be something most likely to be something like he's. And I'll try that again. He's here now, and then I can see you tomorrow at the same time to get the gist of it. And what time do you want to see you guys hungry? The other girls are you. Clearly nonsensical, yeah? How do we get from this idea of choosing the next word, the next probable word, into something that makes sense? You see what I'm getting at? What is it that can get intelligence imbued into this? One thing that was the technology we had before, which has been around for decades now, like, oh, what's the next probable word? But, going back further still, has traditionally been really computationally expensive, really, really difficult, and very memory complex. I remember my very first phone had that kind of thing. So with the advent of transformers, this architecture, what you see on screen, this self-attention mechanism with parallel processing, we're able to store and evaluate a much larger context window. Because right now, it's literally just the word before. Yeah, it's just one word or two words at most. What if we're able to take in a much bigger context window when making future predictions about things much better? Yeah. Now, a few things about context. It is not persistent. It's ephemeral. We know that word from Lambda. Okay. So that means when I go off and talk, when I start up a new conversation, there's always an upper limit as to the number of tokens that can actually be remembered in each context. So that's why you kind of feel like you've lost a friend if you start a new chat conversation. It's the same practice as the glide gesture on smartphones to figure out what word you're trying to. Yeah, it's the same thing, just with the amount of the likelihoods of things being what it thinks you're getting at. It's never really certain, and that likelihood is what we see here. Yeah. This means that the initial information about that model that's being used, whether that's for gestures or words, is going to come in through. And I don't want to get into this, so let's start.
Which is always the same.
I'll get into so this is what's happening. Okay. All right. If you're willing and able, yeah, let's get a bit more technical. So the underlying architecture of ChatGPT and other large language models too is that of the neural network. It's the neural network, so called this because it mimics the neurons, the things in your noggin, okay, or the network of the human brain. So human brains, dash your noggin right here, they can have about 100 billion different neurons, and each of those neurons, they can have about different connections to one other, to other neurons, and then they can fire off electrical signals between those connections at a really fast rate. Again, depending on the electrical signals and gradients and so on, blah, blah, blah. Now, those signals between synapses, they send between each other. They're not random exactly. They do depend on the connections and the strength of those connections between them. I'm not kidding. Like with I used to play a little bit, and I would just visualize, and this probably did. So when I was serving in tennis, really bad at tennis, right? But I tried to learn the action of lifting up and then putting your elbow back and slamming, okay? And in my in my mind, I was imagining or visualizing my synapses like learning the gesture so that it could then imbue itself further. Like it probably didn't work, but I'm trying to reinforce that connection. So I'm trying to get my brain to mold and get those patterns right. Yeah, that's what's kind of happening here. It's what we call weights between neurons. Muscle memory, exactly. Thank you. Muscle memory is a real thing because that memory relates to the weight or the kind of the strength of the relationships between your neurons. Okay, so artificial neural networks are set up in that same way. So, what are you referring to? The gesture thing with these, or learning how to play tennis? Probably the latter. Tennis isn't real. So with that then, artificial neurons, as we can draw the analogy from brains here too, they're connected to each other. This kind of input output thing, because what we're doing is we're sending signals, or we're not sending signals, depending on the strength, on that strength between different inputs and outputs, is what we call weights, okay, W in that context. So those connections, if you keep reinforcing those connections, if you keep saying thumbs up or thumbs down to your ChatGPT conversations, it is favoring or disfavoring weights of those connections. Now, why are neural connections, both in your noggin and artificial, good at many different things like you are? Well, are you ready for this? Don't know. There's no actual theoretical reason why this network is better than other networks or that kind of system. It's almost as if, nature and a couple of billion years of trial and error, they came up with something called evolution. Have you heard of that? That kind of worked? Yeah. Oh, yeah. So that is evolution. It's just a fundamental theory of nature. And evolution and a lot of AI simulations always play into this idea of like simulating what would happen in kind of contrived scenarios or like inputs and outputs, blah, 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 blah. But this is just evolving and getting better and better. Okay. So the underlying structure here is you've got a big old neural network with some 175 billion different weights. Again, weights that have come from a lot of training data, as we discussed, and all those numbers. So when the model crunches them all together, multiplies them together, they ultimately determine what the next word might be, given the probability of adding text, or in the kind of sense of gestures. What the hell did Will just mean? Like, oh, it's probably a G. Was the highest probability of that gesture was a particular phrase or a particular character. Okay, so scientists, they get these model weights in a pretty simple way. They just give the model as many examples as they can, and then they play with it. That's what you do in SageMaker. In SageMaker, you just play with the weights until what comes out this other side looks like those same examples going in. It's art imitating life and all that. Okay, and that is that tweaking of training of the neural network is done by two used methods of word prediction, and I'll get to them. Okay, so let's say we give a model these examples based again on all its current weights, weights which again have been molded by a large body of training text, like everything in Wikipedia and all the books in the world. The model is going to generate a list of probabilities, P probabilities, for each word that it knows. So what's the next likely word? Okay, from that, it's going to then choose the most likely one. Simple, yeah? What comes next? But how do we know what comes next? I mean, going back to my phone, where's my phone? This example of like, what's my next thing? How does it know whether one's right or wrong? Like the modeler's answer to its current weights. How does it know? Definitely a clone, definitely maths. So with each of those words, it's assigned a number, right? What we want to do is we want to give each of these words here a little bit of a number. Remember, so these tokens come through. We embed these tokens, that is to give them a number. And then if the model then chooses a word that is most, mathematically further away from the numbers in the body of the training data that appear in similar frequencies, then we can apply statistics onto this to then adjust the weights to bring the model closer to being correct. We can play with that there. So here's a related example from Stephen Wolfram's book on ChatGPT. So instead of words fitting a sentence, like he's using a bit of a linear regression problem, so like lines essentially. Sure, you know what? Maybe that's a good point to take a break. I think before I'm frying any brains. Let me just finish the point, and then we'll take a quick coffee break. So taking things very well. Me, I'll get to the break. I know. What I'm saying here is like, if you've got your neural network, if you start with something like a straight line, yeah, and you're trying to get a line to fit into a specific shape, into a specific mathematical function, every time that the model guesses, you can start to calculate just how far off from the correct shape were you. Yeah, just by looking at the x and the y coordinates, and then where they should be, like how wrong was it, how right was it, and then we can start to play with the weights in the model to try again and try again and try again and try 10 million more times, and then eventually you're adjusting the weights in that neural network to decrease the wrongfulness, of what statistics would call loss, a loss function, loss in that sense being how wrong were you, so that if your model is working over time, if you're getting it right, your loss is going to become more and more minimized. your loss is going to be minimized. Okay, and the model will start reproducing examples more appropriately. This is again just with a linear regression problem with lines, but in the specific case, the right mathematical function. How do we do that for words? Power, bit of force, a bit of brute force. But in order for us to get power, I do think we deserve a bit of a coffee break there too. So when we think about coming back, we'll talk about how we can apply that to words. Yeah, so we'll do natural language processing 101. Funny thing just happened to me. I was literally thinking about weights as we came out of the conversation, and then I went to reach my phone, which I've recently changed one of my apps to be somewhere else. Like my home screen has been rejigged, and my muscle memory was so used to just reaching for that app I wanted that it no longer is where I wanted to. So the point is that I changed my apps about, and again, muscle memory, this entrenched idea of where things should go. My connections were so strong that it got it wrong, and my kind of idea was I wanted to click on that thing, and I know it was elsewhere. So I might have to go back just because rather than retraining myself all over again. Art imitating life. Now, if we're back, if you're ready to go into a little bit more of a discussion, how that works, what we're thinking about, just like we saw with numbers, what we're doing is what makes words different is that they are literally just assigning a number to every word in the English, in the whole language, So when you ask the model anything, like there are about 50,000 numbers for it to kind of go from, it looks up what query corresponds to which in number words. And then it runs each of those numbers here against its 175 billion different weights it might have learned. That's the neural network here in blue, and then outputs another list of words in the English alphabet with p probability after which it goes off and cherry picks the most probable, the most reasonable one. iOS 26, are we talking about the new Android S26? Am I completely off there? Because I saw the new Android 26, or the new one. Android 15. No, the one that came out like today. No, by Apple. I mean, oh, okay, yeah. I'll show you this one first, real quick. So if you, it's just, oh no, I actually quite like it. There's a lot more kind of rejigging about. A lot of things are more responsive in the box department. Quite a bit of fade. Now they, like Google and Apple and all the other Androids are becoming more and more the same. So pretty much the same thing. Bit of a nice animation there too. I've got an Android phone, so this to me is what's going to happen. I do have the island as well. That's not an Apple thing anymore. Like my phone does that too, where I can get things kind of. I never use it, but it's nice to have, and other things too. It does look cool though. The new, was it iOS 26, 27, 26. So if you've got an iPhone, expect to see cool things soon. Phones have come to the point where it's more about refinement than revolution. I remember a time and a place where all the phone hardware manufacturers they were competing each other with really crazy designs. I was considering going back to BlackBerry. I never had a BlackBerry, but I like the idea of having a keyboard with it. If only just because it's a nicer, flatter, it's more horizontal when it comes to side scrolling and the like. So I quite like that with phones. Otherwise, eventually, Apple are moving into foldables too. That's going to be the future, I believe. This is 26, right? AJ, the kind of faded, this background. Apparently, it's quite hard to see things, which is maybe something. Yeah. So, the Android still has color, but Apple are going full circle. They've gone back to black and white. Apple are going with foldables very soon. You'll see. What was I going to say about that? I can't remember. Oh yeah, but it's a cool one. I think the banana phone. Do you remember the Nokia banana phone? This is a real thing. I saw one in an airport recently. You can still buy them. They're really cool. So, okay, let's take that for example. Way off topic, but if I were to put something in like, does anyone get that away? Does anybody remember the banana phone? I would hazard a bet that those two words are pretty low on the probability score of the next most reasonable one. Yeah. Now, again, if you do this for enough periods of time, and OpenAI did this for the equivalent of many, many years, you can start to look at the numerical differences between the examples that the model gives you, as well as the outputs, in order to minimize that loss. And therefore creating something that just sounds like and looks like what humans have written, or will write, or can write. And all of this, however, I mean, they're not going to get you a bot that seems to understand context and generate text in a human-like way. We're still getting fancy autocorrect. For that, then, we still need some way to associate words with each other. And again, ChatGPT does this with numbers. So, for example, if we assigned every word in the English language with a number, and then we statistically determined how often each word is to another word in like everything humans have ever written, basically, then you could have a graph that looks a bit like this. Okay, again, like this is just a 2D thing, but words aren't randomly on them. Okay, they are grouped together, they're clustered together in such a way. So, for example, car and door, they appear more frequently in training text than, say, degree in science do. And both pairs are further away from each other than, say, history is. Interesting. You might be thinking that, okay, given the richness of human language, that the relationships between the words have to then represent more than just a two-dimensional space. And I'd agree with you. You'd be right. This ChatGPT seems to think so because ChatGPT has learned to represent the wordedness of words, not in a 2D space or a 3D space or even a 4D space, but in a 12,228 dimensional space. So we have in front of us a two-dimensional example. So what we're seeing right now, I showed you before a three-dimensional example, so you can get the basic gist. A 12,000 dimension is some Ildrick madness that I literally cannot visualize. It's incomprehensible to us. But, okay, we don't have to go crazy trying to visualize 12,000 dimensions mathematically. Why don't we instead think of this a bit like AJ's matrix, a big matrix of sorts, yeah? Like, not like the Matrix 4, a useful matrix, a matrix that everyone actually wanted. So if every word in the English language was assigned then a number, we could represent that word, we could encode that word with a 1 instead of a 0 at that point in a 1 times a 5,000 or so matrix where that word would be in the full alphabetized word list of all the words. So I've got here aardvark will look a bit like this. So with a 1 being at the first index and then 50,000 or so zeros, actually 50,257. And then Aaron would be looking like this. So going through the English language dictionary, like one word next to the other. And then the longest input that ChatGPT accepts will be 2048 words, so that the matrix for a query into ChatGPT would be a matrix of mostly zeros, that is 2,000 by 50,000. But remember, like through that training data, ChatGPT has stumbled onto 12,228 or so dimensions of that wordedness, you know, of things that are able to produce that human-like responses. So if we multiply them with 2,000 by the 50,000 matrix that encodes all the words, that turns them into useful numbers, and by a learned 50,000 by 12,000 wordedness matrix for every word in the possible English language, then that returns a 2,000 by a 12,000 matrix that transforms a text input into something like ChatGPT that can actually use and see. And this big old matrix, that's what we call an embedding, a mathematical attempt to represent the essence of a thing, a numerical soaking, a thing with numbers based on those things' statistical relationships in the training data. And now with the right embedding, a neural network like ChatGPT can understand the context. It can generalize because it's taken in how words are used and how they're related in an unbelievable amount of human text and turn that into maths. So what are we talking about, Dennis? If you join us a little bit late there, I'm showing you step by step what ChatGPT is. You might have missed the first half, but at this point, the bottom line is, Dennis, that the very big part of ChatGPT, the cutting edge technology that really makes it special, is something like I've mentioned before. Have you come across this term before? Attention. Like from a paper here, which you can just Google and it'll come back as the first result. Attention is all you need. Is the paper that was put out by Google researchers. This is the outline, the mathematical way of giving importance. So what we're saying is, how do we give more importance to some words over other words? How can we attend to things? For example, if I ask you, Dennis, how many species of dog are there? And you might answer me with an answer in a very human-like way. You might focus more on the words dog and species. You might think, oh, those two words are more related than other words. Okay, if I ask you, what shoes, what size feet do you have, or what type of shoes do you like, you would associate or you would attend shoes and feet and size, those words more closely. They kind of live in that space more. Now, how it actually does that is they're a lot more complicated here, and there's a lot more complicated maths. But the point is, it seems to work really, really well. Kind of in the way that we use neural networks in the first place. They just seem to work. Like, even though in both cases we can't fundamentally explain why, which may or may not be a problem in the far future or near future. So, as a starting point, the original transformer and the GPT papers, they provide us with this diagram, which is not bad as diagrams go. But if you're like me, if you want to get into the detail, if you want to understand the full picture, let's dig in, right? So, before we understand anything, we need to know what are the inputs and what are the outputs of our proverbial black box of our GPT. I can't type with a mouse. Let's not do that again. What are the inputs? What are the outputs? There is a sequence of n amount of words. So in natural language processing, you're going to hear this word of an n-gram. N words, like basically tokens. So not all heroes wear, okay? And the output here, what I'm expecting from the output, is likely to be a guess. So then if I ask you, not all heroes wear ... what's the probability of you choosing a word? What's the ... if you're familiar with the phrase? Not all heroes wear capes. Exactly.
Means I got choose a word, right? ...
So that's a probability, exactly. And that you've got this gut feeling. Where's that gut? Well, that gut feeling comes from you being exposed to training data, to the real world, from reading and hearing people use the phrase. So you've got that instinct that we're trying to get as well here. The output from this is also going to guess the most likely word to be put at the end of your example sentence. So that's it. That's, all the impressive ChatGPT dialogues, all the stories, all the examples that you've seen posted around. They're made with a really simple input, goes into this kind of space, out produces an output. Give an input sequence, get the next word. Now, after which, you can get more than just one word at a time. That's not the problem, because after we get the next word, not all heroes wear capes. We added the sequence. We kind of put that at number 5, and we ask it again, get the following word. Not all heroes wear capes, but all villains do. And then you repeat as much as you want, and you end up with really long generated bits of text. So I can't remember what happens now. All right, yeah. So to be more precise, we actually need to correct in the 2 above aspects. Okay, the input sequence is actually going to be fixed at 2048 words. We can still pass in short sequences as input, or we can simply fill in extra positions with empty tables. So, but the GPT output is not just a single guess, like it's a sequence. It's going to be of length 2048 of guesses with a probability of each likely word, one for each next position in the sequence. But when we're generating text, we typically only really look for the guesses that are at the last word of the sequence. Okay, that's it. That's kind of the sequence in, sequence out. But okay, so I've told you that GPT can't really understand words. It doesn't know anything. All right, being a machine learning algorithm, it's an algorithm. It operates on vectors of numbers. So how do we turn words into numbers? How do we turn letters into vectors? Well, the first step is for you to keep a vocabulary of all the words, which allows us to keep each word a value. Sure. So aardvark is going to be 0, Aaron is going to be 1, and so on and so forth. GPT has a vocabulary of 50,000 or so. As a result, we then turn each word into what they call a one-hot encoding, a vector size of 5057. So only the dimension that index, like the word's value, is 1, and all the others are going to be 0. Which of course we do for every sequence of that word, which results in a 2000 and such by 50,000 matrix of those ones and zeros. 50,000 is pretty big for a vector, okay? And it's mostly just going to be filled with zeros, which is a lot of wasted space. So to solve this, we might use what we call an embedding function, and a neural network that takes in a 50,257 length vector of ones and zeros and outputs n length number of vectors, where n could be anything. Here, what we're trying to do is store, or really project, the information of the word's meaning to a smaller dimensional space. It's called dimensionality reduction. So, for example, if the embedding dimension is 2, okay, it would be like storing each word at a particular coordinate in a 2D space. Another way to think about that is like each dimension is made up. It's got properties to this, like softness or schmorfness, like how much of a thing it has, and then given a value for each property of each thing, of how like ness of something, we know that exactly of which word is meant. Again, like of course, the embedding dimensions are typically larger than 2. It uses 12,228 dimensions. I cannot conceive of juggling that much in one go. Okay, so in practice, like each word gets one hot vector encoded, gets multiplied by the load vocabulary during the network weights, and then you end up with a 12,288 dimension embedding vector. So just in arithmetic, what we do is we times 2048 by 50,000, that sequence encoding matrix, by the 50,000 by the 12,288 embedding weights matrix, the learned one, and then we end up with a 2048 times a 12,088 sequence embeddings matrix. And I think from now on, like I'm trying to draw these as little blocks with the dimensions written next to them, because try to separate the matrix lines just to make it clearer as to what corresponds to a word in each sequence. What this means, though, is that far in the process, further down, there's no information flowing across the sequence, no information or the absolute or the relative position of tokens anymore. So after, and this is what I was getting to earlier with the positional encoding. If I can go here. So you also want to encode the position of the current token in the sequence. So that you might put this into a sequence. Let's go and have a look. So GPT-2 trained its own positional encoding matrix from scratch. Okay, fine. The result is that for each token, a 12,088 vector of numbers, just like with embeddings, we can combine those vectors into a single matrix. And where would that be? Okay, multi-head attention block inside of which, well, it's like this, okay? And then that where each row is going to be another positional encoding of the sequence. It's quite picky, sure, but just to encode the position of the current token with a sequence, you would take in the token's position, basically a number from 0 to 2047, and then pass it through 12,000 sinusoidal functions just with a different frequency. The result is that for every token, a 12,288 vector of numbers, just like with embeddings, combine that with the vectors into a single matrix where each row is now a positional encoding. Finally, so this sequence positional encodings matrix, it's got the same shape, it's got the same sequence embeddings matrix. We can simply just add on to that at the end. All right, so we've seen encoding. Try to look at what, after the encoding, comes that of the attention block. So after we've somehow got numbers from words, we need to turn our attention to attention. Okay, simply put, the whole purpose of attention is just that for every output in the sequence, you try to predict which input tokens to focus on and by how much. So here, for example, I've got a sequence of 3 tokens, and they're each going to be represented by a 512 value embedding. So this model has learned that 3 linear projections, all of which are going to be applied to the sequence embeddings. In other words, 3 weight matrices is going to be learned, 3 synapses. That means we've transformed our sequence embeddings into 3 separate 3x64 matrices, each for a different task. So the first 2 matrices, Q for queries, key for keys, they're going to be multiplied together. So you times that by this, and that gives you a 3x3 matrix. Okay, and this matrix, again, you try to normalize this through an algorithm called softmax. Algorithms can perform dimensionality reduction. You can kind of get the gist, if you will, and that represents then the importance of each token in respect to the other ones. I'm using the same word here, but what we're doing at this point, if I can just illustrate perhaps better, is this is the each token's embedding is transformed into 3 vectors: query, key, and value. These vectors are then derived by multiplying the input embeddings matrix with the learned weights. So is the search text you type into the search engine bar the token that you want to find more information about? Key is the title feature of a page in the search result window. It represents the possible tokens the query can attend to. I'll just send you this website. It's a pretty cool one I found earlier. At this stage, you're trying to show the if I can get like a better, let's say, does anybody remember the banana phone? I guess the weights. Does it show me with a bit more? Here we go, somewhat, okay? So that's what I'm relating to. Like, clearly the word, that's not a very clear example. Let's go back to all heroes wear capes, just because that's a phrase that we can agree on a bit better. That was me being a bit funny. So a phrase that we might be more used to, take it with a pinch of salt, for example. Let's go into that one. Come on, listen to me. So it's a little bit slow. So take it with a pinch of salt. So let's use that. So how in the attention block here, so the dot product is when we times them together. So there we go, that's the softmax operation. So after which you've applied a little bit of normalization steps just to clear it up, just to get rid of the empty space, if you will, plus dropout. These are again algorithms that help with cleaning up the data. You now represent the importance of each of those tokens in respect to other tokens. So how does that really come through? After a couple of attempts, that is, like, to me, it's just not immediately obvious or clear how this works. This website I'm referring to. Maybe later. At this point. So this is the case. The query, the values, the queries, the keys, and the values, those values are going to be multiplied against this matrix, resulting in that for each token, a mix of all the other tokens weighted by the importance of the respective tokens. So if the importance matrix, like I'm using the matrix here as a 3x3 matrix here, is going to be just ones and zeros. Each token has only one token that's of importance, right? The result is like we're just selecting the rows in the values matrix based on what token's most important. I know, like, it's not the most intuitive understanding of the attention process when it's kind of in algebra, but what we have then is something called a multi-attention head. Now, in the GPT model, they use multi-head attention. All that means is that the above process, all that kind of faff, is repeated many times as 96 times in the ChatGPT version 3 version, each of them with a different learned query key value projections, the weights, in effect. Just think of them as being the weights. And the result is that each attention head, that's the 2000 by the 128 matrix here, each attention head is going to be concatenated all together, which gives you altogether a 2000 by 1028, which is then multiplied further with a linear projection, which doesn't change the shape much, but again, for good measure. Honestly, I can't even work out some of those things. Okay, so then you've got something called the feed-forward network. The feed-forward is like a good old multi-layer perceptron with one hidden layer. That means you take in the input, you multiply that against the weights. This feed-forward network here, you just do it again and again and again, and then both the inputs and the output shapes are pretty much the same, but there are hidden layers in between. Okay. We're almost there, okay? After we pass through 96 or so layers of this attention and self-attention of this neural net machinery, the input, basically your input token, whatever you are, ChatGPT, has been processed into a 2048 by 12,088 matrix, this dimension space. And this matrix is somehow supposed to contain for each of those 2048 positions in the sequence, a 12,088 vector of information about which word should appear where. But how do we then extract that information? Okay. Well, if you remember back in the embedding section at the start, we learned that there was a mapping which transforms a given, so a one-hot encoding of a word, into a 12,088 vector encoding. So remember, like the embedding function, which was a neural network that took in a vector of ones and zeros, and then it outputed a very slightly differently length vector of numbers. And then that was to try to store or project the information of the world's, of the word's meaning just to a smaller dimensional space. It turns out that you can actually just reverse that process by mapping that input to our 12,028 vector space and then back into a 50,000 word encoding. That is, so if we spent all that energy learning a good mapping from word to numbers, well, we might as well reuse it. We can actually go the other way around. Of course, it doesn't give us ones and zeros like we started with, but that's a good thing because after a quick softmax, you can treat the resulting values as probabilities for each word as well. And there you have it. Like it's a pretty strong. It's pretty strong now. After a couple of matrix multiplications, some algebra, you have a do-it-yourself kind of natural language processor. That's a monster, and I think we are ready to see. That's the whole architecture. Fundamentally, I know that's a lot, but it's a full architecture. Judging by my math, probably yours as well. I'm going to give another opportunity just to go through this again. A little bit fast, a little bit double speed now, this time. Sure? So if you give ChatGPT a prompt, what it's going to do is going to turn that last word of the prompt into a prompt of numbers. We encode it, okay? And then it multiplies that number. So everything that is learned about how words are associated with each other in the English language, or our embeddings, that's going to give us a 12,000 dimensional matrix. That's how it sees the world. Then we run this matrix and all the numbers associated with it through this attention transformer that we talked about. So that some words in the prompt, or the last word in the prompt, are paid attention to more than other words in the rest of the prompt to generate that output. With this, we then normalize that data, try to smooth it up. We try to get something a bit more in terms of what we started with in terms of matrices. And then we feed this forward to the next layer of the attention transformer and do it all over again. How many times? We do it 95 more times with this version of ChatGPT. And because there are 96 layers in ChatGPT version 3 where this is taken from. And then after that, after all this data gauntlet, we basically do the reverse of what we started with. We take that big old matrix of numbers that we went, what came out those 96 layers, and then we just reverse the embedding. And so we use that 12,000 dimensions again to turn words from numbers. We get words from numbers. And then after that, you get a single word. After all of this, you get one word. And so you can imagine that, like, if you have to do this for every single word, we do that calculation that involves 175 billion separate operations. It can take a large language model a long time to get back to you because for each and every single word, that's why there's a bit of a time delay. Yeah. You'll notice that even with all of this too, at no point does ChatGPT know anything about you, let alone know anything about what you're asking it. So we start, for example, here. So what is the sixth element on the periodic table? The neural network is not thinking about the periodic table. It doesn't even know what atoms are. It doesn't even know who you are. It is just determining, this Pandora's box, this gauntlet of data, the statistical distribution of words in that training text. And all that it knows, what's the most likely word to follow the sequence of what's the sixth element in the periodic table? And then, a reasonable next word based on everything ever written online by anyone ever is carbon. That's it. Easy, in a nutshell. So that's sort of how ChatGPT works. What's next? I mean, obviously, we started here with other discussions around other use cases too. People are really excited about the technology, and it's the best chatbot ever because it can summarize, unreadable amounts of text. Other books you might have, it can write poetry, it can generate code for you, things that you can actually use, and that's awesome. Yeah, but I think there is still a really large risk if we don't migrate it to our information ecosystem because here we fundamentally do not know how ChatGPT came up with the embedding that it did, or how it, out of all the 175 billion different weights, it cherry-picked the one that we got. It's non-deterministic. Of course, that's not that surprising because ChatGPT is a neural network, and can you explain a brain? If it operates like your brain, you can't really put into words why you thought that thought. Yeah, you can't even tell me your decisions. Like, why are you the way you are? Huh? Why are you the way you are? Sounds like a drilling, but yeah. Can I do NFTs to make money? Why did you ask that question? So what made you, of all the things that you could have thought, why did you make that thought? What does your brain look like on the inside? It's like this. Okay, let's go and let's get an NFT. Dog NFT. So this is I'm gonna get your NFT right there. Okay. So if I get you a doggo, if I get you an NFT a bit like this one, I'm gonna get you a doggy just to show you. It's an adorable little guy. Maybe he's not so adorable, but you can imagine this guy's looking kind of cool. Why is he the way that he is? Why is this a dog? Why is it the thing that it is a thing that it is? You might tell me, well, it's obviously it's got a cute little snout, it's got little peats, it's got a little face on him, little snout, little feetsies. But the more you start to go down that line of questioning, you start to realize you don't actually have a full description of what dogness really is. You can't really describe how your brain arrives at puppytude, at dogitude. I can't remember which. I think it was Plato. He comes up with this idea of like misremembering this. Plato describing kind of of like chairness. It's just like the sense of higher self. Yeah, in the theory of forms, right? The ideal, the perfect, the unchanging concept that all chair share. And like chair is just an example, because what else do we share with ancient Greeks? But this idea of the thingness of a thing, the more you start to put pressure onto that question, you realize you just lack the thing. If you take a couple of if you take a chair, if you remove the foot from the chair, all right, so it's a broken chair. But if you keep doing that, at what point does a chair not become a chair? It's like the what was the allegory about the boat? I can't remember. Philosophy about a boat with replaced parts. Is that I'm making this up? Theseus paradox. Yeah, the ship of Theseus. So if a ship is gradually repaired by replacing each of its wooden parts, so from start to finish, yeah, you're just kind of you're changing a little thing here and there over enough time. Each and every one of those parts has been replaced. Is it still the same boat? At what point did it stop being that same boat? There is no spoon. There is no spoon, Ades. Yeah, exactly. So we can't explain. That's a great throwback. So I like that. So similarly, again, just for neural networks, I mean, we can't right now just open them up and see exactly how they work and what they're doing. Yeah. So give it a break. We've had the same broom for 13 years and you've decapitated almost 10 times. So I don't know at what point, that Frankenstein broom, the concept of the broomness, it's really hard to put into words. At some layer, how does what this really is just kind of recognizing patterns, right? Recognizing pictures or shapes. At the first layer is going to go and look for cat-like shapes or dog-like shapes. But then at the 10th layer of its brain, like, what is that? How does that describe Katniss Everdeen? We can't right now. But if you look into something like ChatGPT and you're figuring out exactly how it's working, we just don't know. And that's important to understand too. It's really hard to kind of get there. But what is interesting is that it seems to get it. It seems to know enough about our human language that we're just that obvious, I guess. We're that deterministic or producing human-like responses that it could now pass a Turing test, and that it could be used in science fiction, that it is able to bend the spoon. Just a few months ago, that seemed to be like the ultimate problem. And then within a few months, actually, the Turing test was easy peasy. It's blown way past it to the point now where it's a lot harder. It appears that human language is computationally much easier than anyone thought previously. It's now there are maybe laws of language to discover, like there are like laws of physics perhaps, and so with ChatGPT 4 and newer ones too already being a step towards artificial general intelligence, or like a super intelligence, who knows who these systems will figure out, and but we'll be unable to tell them apart or how or why. So I think maybe the striking success of ChatGPT shouldn't have been all that surprising. Again, it's been about how many connections between those weights between those connections in the brain as there are neurons in your brain. And maybe it just happens to be that a neural network of sufficient size, it can handle a problem as complex as human language, but maybe there's more to it. Maybe there is. I don't know. For time. I've got 10 minutes too. That's probably where I would reel it in and start talking about other things too, folks. The point I was getting through with this is that I didn't want to bore you to death with the transformer architecture. Like clearly, for us now, like especially coming in from a cloud angle, we don't need to know this stuff very much, right? How many of you have even heard of a attention transformer before using the tools? Kind of us steering into cloud, not all of us, myself included, didn't come from computer science. I didn't come from a programming background. And I wasn't really jazzed out about heading in that direction until, for instance, like November 2022, when all of a sudden it seemed for a lot of people that the world is now just changing. And maybe this isn't such a promising path anymore because AI is going to come and take our jobs. In fact, maybe like, will robots take my job as a website goes from time to time? Such a lucrative path anymore. It seemed like for a long time that that human creativity was always going to be the last forefront, or the bit that robots would take the longest in replicating. How wrong we were. It was the first thing it got right. And the things that we thought we're going to do, we're going to fall first, like manual processes. I still don't have a robot dishwasher, but I can, Gen AI some images in no time at all. So we got that one really wrong. Anyway, let's go and have a look here. Cloud architect. I think, everyone's got their own. I'll go for this one. That's a bit. What's this? Let's have a look. What's Dennis giving me? Produce an image where the head of the animal is half cat, half dog. That's I see the dog ears, I see the cat nose, and it's more of a oh, look at a little face. Did you come up with this, Dennis? Is this your prompt just now? Kind of cute. Funny how it's been played up in the kind of
Yeah,
room
it
where it's
is.
just nice.
Well, it just looks like it came to me. I don't know why.
Ask it if you're willing to ask it to produce an image of what it thinks you look like. So, or phrase it in such a way to say, take into account all of our conversations thus far, ChatGPT, know what you know about me, and then produce an image of me or what you think a description of me might be. I've seen
Oh,
the
that's
ones
gonna
like
be
that.
weird.
Yeah, I'd see if I've got mine around somewhere. I also had another one, or like produce my bedroom was another one as well. So you could say, just given what you think, our conversations and my interests are, produce my bedroom. It's really cool. Again, that's the context window that comes into these things. Again, the potential here to disrupt, like even though I just offered I think time will tell as to who's right and who's wrong as to how this all plays out. Like I do think that if your background is in practical skills entirely, like just being really well versed in one thing or just a few things like HTML or CSS, older technologies, well, anything that a computer can do just probably better eventually or do better than you and me. Therefore, I think having a well-rounded foundation in what you can do in multiple technologies, multiple languages, multiple fields of science as well, is all the more empowering. So you're really that one person who's developing new technologies further down the road and mastering the same when it comes to specific things. Just be mindful of the tasks uh, that maybe just become a bit more repetitive for yourself. Like this one isn't that repetitive. So things that are a little bit more redundant, such that even if you're inclined to reach for tools that would make your life easier and faster, try to stay ahead of those tools. Okay, try to get ahead of those trends, then make sure that you're learning and then applying more sophisticated skills than those that clearly software can already automate. I'm going to try as well. See if I can get that prompt going. Dennis. So I'm going to ask it to tell me what it thinks about my room. Um, mm, 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 mm.
It won't produce a picture without a prompt, without you uploading something or whatever. That's what I noticed.
Mm, yeah, I'm gonna. Where's my phone? There you go. You can see this, right? So I'll just give you the prompt. How can I can't give you the prompt. Wait, can I give you the prompt? If I copy this, how can I get that? How can I get my phone to talk to my computer if I'm like emailing myself? Gosh, no. Uh, how can I get it to myself?
WhatsApp? WhatsApp?
Yeah, but I don't want to go to WhatsApp and it's like there should just be easy ways of doing this. But yeah, go on then. Let me WhatsApp it to myself.
Are you is that just another web page you're on?
No. It's on my phone. What I'm doing is I'm beaming my phone to my computer, and you're seeing my phone, but I'm interacting with my phone.
So you should be able to throw it onto your Google search engine. If not, open a new window that way.
Oh, that could work. Yeah. Now the problem is I can't type in my. Oh, stop sharing. I'll just reshare. That'll be easier. Okay. Select all. Okay. Search. Cool. And now if I go to my Google history, because I was on the Google engine. Uh, yeah. There you go. There you go. So give that a go. Ask the GPT what it thinks of you. Who knows what comes up? And this is where I saw Spider-Man the other day, by the way.
In your room?
Not in my room. He
Well,
was.
mine is generating my room. It's got a whiteboard with lambda, lambda, and all kind of
Oh yeah. Let's have a
actual
look.
laptops. Oh, that's a good one, actually.
Do you wanna show us?
Yeah, I just said create what an image of what you think my room looks like. But it's kind of cheated.
Yeah.
I don't think it's correct.
Try again. I'll say just keep going or try again.
I think what it does is looks at all the stuff I've been asking it and just stuck some diagrams there and a couple of laptops and two
Yeah.
pages. Like that's all I've got in my room, right? I don't have a life.
Well, context windows are a funny thing. So, no, I actually want that page open. GPT context windows between, because you can enable this in the settings somewhere, between conversation, between chats. If you want to disable this, you have to go to your settings and turn this off. That's not what I'm asking for. There is a way to do that. Can't find it. Oh, let's have a look. So, Dennis, how fun is this?
Surely my life's gonna be more than that, right?
What I think. So I'll tell you who I think you are, Dennis. I think you are into networking. Is this a Raspberry Pi?
It is I do have a Raspberry Pi, but I've never entered it into chat at all. But
Interesting.
that must be some deep
Yeah. Well,
deductions.
it's funny though because you could be into. Mine didn't come up with this. I didn't haven't asked any questions. I don't know how he got that right. So right. This is oh my goodness, that's very CloudWatch-ish, isn't it? That's like the services in the management dashboard.
Yeah,
Bit of like definitely some AWS-ness going on here. That's VS
yeah,
Code, right?
yeah. That's what it looks like. Yeah, that is VS Code. Yeah,
VS Code and
that is
AWS,
crazy.
which is why it's informed so much by your architectures. IoT, talking to
So,
Gross.
so that means I don't talk about my life at all. I just what it means. I don't have a
What is it
life.
like? What do you have to remind yourself of? Remember, number 63, okay, Dennis? Number 63 using Tor only. Don't forget that. Your sticky notes there. No set. Oh, no, so you haven't been using it much. Doesn't okay, well, now's the time to. It's
It's
funny.
just
It's very clever.
yeah, but my desk definitely doesn't look like that. Though. It's an absolute tip. That's what it's got wrong.
If you insisted a bit further, would it try again? I'll try
Yeah,
again.
I'll try your prompt.
So I also did, but um, so this is one as well. I did. Let me give you that prompt. So I just generate a room that represents my personality based on the conversations we've had thus far. Okay, this is brilliant. I've got you. Picture this. That syncophancy, that theme. I'm training it really hard to stop doing that, but it's got a mind of its own apparently. Here's mine apparently. Oh, it's a bit of a slow. Come on, slow. Does it describe your room? Does it talk back to you, Dennis? Does it tell you?
Let's see. Yeah, it does actually. Oh yeah, yes. It's got imagine room elements, dual monitor. I do have two monitor, whiteboard. I do have a
Yeah.
whiteboard, sticky notes, which I really don't have. Small stack of AWS set prep books, which I don't have. Dark mode
Uh-huh.
UI team. Okay, that's neatly stacked folders. I've got that. Windows slightly open. Nope. I'm in the dining room. Right. Visible
And
rooftop modem or Pi board. Okay, I do have one of those. And I'm interested in Internet of Things. And then
uh-huh.
quiet mug of coffee. Yeah, a couple of empty plates that should really be in the
Yeah.
sink like hours ago. Right.
I think yeah.
Uh,
I, I won't judge because who am I to? I literally have. It's been worse. It's been better. It's worse. It's yeah. So this is what we call a multimodal. It's multimodal. It can both produce images. It can also do the next frequency thing. Um, I definitely don't have sudo make me a coffee, and I void warranties. You're such a how dare you?
sudo. That's Linux. That's Linux command, isn't it?
Yeah, yeah.
Yeah.
Sudo make me a coffee. I'm gonna get that on a shirt. I like that. Yeah, that's quite funny. There's a great channel I'm following now called Computer File. You strike me as a person that might be subscribed to them, Dennis, on YouTube, perhaps. So
Computer file.
if this guy, he's let's just
Good
quickly.
night, AJ.
Yeah, sorry, I just messaged as well. See you next week, AJ. I think so. It's gonna be a busy one, but thanks again for staying. It's been a lot of fun, an absolute pleasure. Before you go there, Jay, I was going to suggest if these things are interesting, this channel's brilliant for getting through with it. And right now, I'm kind of interested in how images are generated. There was one that was really cool, and we were talking about this like the dogness or the puppiness. Then this student wrote a custom program that kind of captured the essence of Castles and his instructor, who's running the program, running this thing, and kind of playing with the weight of the distribution between like him and Mike Wazowski and like how it distributes more on one side or the other. It's really interesting. I'll show you. We talk all night about this stuff, but I think we're gonna have to park it there for the evening, gents.